Today we're going to talk about finding the area of similar figures. So remember, similar figures aren't congruent. So it's not like one triangle and a second triangle that are exactly congruent to each other. It's one triangle that's proportional to another, or one rectangle that's proportional, one pentagon that's proportional. So it's not that they're the same, it's that they have the same ratios for all of their corresponding sides. So the way that we compare the areas of similar figures is a little different. So let's say I have this rectangle and one of its sides is 8, one of its sides is 3. So the area of this rectangle is 24 centimeters squared. So let's say I am going to take my original rectangle and I'm going to multiply the sides by 3. So I'm going to call that number, I'm going to multiply by what's called a scale factor. A scale factor. So I'm going to multiply all of my sides, in this case, by 3. My scale factor can be anything. So that new side, that new length, 8 times 3, that new side is going to be 24 centimeters. And the new width, 3 times 3, the new width is going to be 9 centimeters. So the new area of this rectangle is going to be 9 times 24, which is 216. Length times width, 216. So you might be thinking, okay, Ms. Briscoe, I took the side and I multiplied it by 3 to get my new side. I took the width and I multiplied it by 3 to get my new width. Wouldn't I take the area and just multiply it by 3 to get the new area? Well, 24 times 3 is not 216. 24 times 3 is 72. So I cannot just take my area and multiply it by 3. Actually, if you take 216 and divide it by 24, you get 9. So we're actually multiplying the area times 9. So if we think about, okay, I'm multiplying my sides by 3, I'm multiplying my area by 9. What's the connection between the scale factor for the sides and what I'm multiplying the areas by? Well, I'm taking my side and multiplying it by 3. I'm taking my area and multiplying it by 3 squared. 3 squared is 9. So the big idea is if I have a dimension is a word for a length, a width, a height, a radius. Those are all examples of dimensions. If I take a dimension, multiply it by my scale factor. I'm going to use SF for scale factor. Or sometimes you'll see scale factor as K. I don't know why, but people just use the variable K to represent scale factor. So if I take my old dimension and multiply it by my scale factor, that's going to give me my new dimension. So back to this example, I took my side, that was a dimension, I multiplied it by my scale factor, and that gave me my new side. So dimension times scale factor gives you new dimension. But if I'm going to take my area, I'm not going to multiply my old area by the scale factor, I'm going to multiply it by the scale factor squared. So I multiply my old area by the scale factor squared to get the new area.